What's up YouTube, my name is Ali and welcome back to another video. Today we're going to be starting a new series on embedded development, and to get started with that we're going to be setting up our environment, so installing any software, configuring our IDE, that sort of stuff. So to get started, let's have a look at our text editor. It's the basic thing that you will need for any coding. If you've done some before, I'm sure you probably already have your own environment. I use Visual Studio Code because it suits me well, I've got it configured nicely and I like it. You can use whatever editor or IDE you want, as long as it suits your needs. So to program in embedded, you normally use C or C++. For the devices that I have over here, we're going to be using mostly C, a little bit of C++, and two of these are AVR devices, and the third one is an ARM device. It's a bit more powerful, and this will be covering a different series for advanced C++. But to get started, we're going to need to install our libc and our compiler. So the libc can be got from non-GNU, not official, but it's the best thing. It's pretty good. It has support for most of the Atmel Mega and Tiny, all of it basically, and it has all the features you need to get started with a few basic things. If you're on Linux, it's very easy to install. Use your package manager, in my case apt, and install AVR libc. And I've already got it installed, so this should come up in a second or two, and it's already installed. Next thing you're going to want to do is install your compiler. So if you're on Linux, again, it's very simple. It's just GCC AVR. This is currently the only one. LLVM or Clang doesn't support AVR officially, but you can get some ports. To install this, again, very simple. Just use your package manager to install GCC AVR. If you're on Windows, you will need to use a tool called Mingw. This is a minimalistic GNU environment for Windows. It is very well supported. You can get it from their website here, which I will have linked down in the description. And it supports both 32 and 64-bit Windows, so you should be perfectly fine with using that. So, and just to show, I've already got this installed. Now, the version that this installs is actually a slightly older version. It is 5.4. And if I just make this a little bigger, you can see how it's been configured. But we don't need to know any of that right now. So now we have our libc installed, and we have our compiler installed. Next we want to get some basic code. So I've got here a very basic main, just has two different while loops. So you've got the while true loop, which is here. Alternatively, you can use a forever loop, it works in exactly the same way, it's just a slightly different way of writing it. I've not got anything else included in this, and you'll notice that if there's a forever loop, this isn't going to return. In embedded, you never return from main. You always have an infinite while loop, because if you return from main, what's going to happen? If your program exits, well then your device isn't doing anything, so it just reboots. So you always want to have a forever loop at the end of your main, just to catch anything, unless of course it exits and you do want it to restart for some reason. So to compile this, we are going to do AVR GCC, we're just going to give it main.c, because this is what you do normally. And if we have a look at main.c with file, sorry, not main.c, a.out, the file it produces is an AVR 8-bit binary. And if we have a look at the size, we can see that it's only 10 bytes, which seems about right for the amount of code that we put in there. But if you know about libc, you'll know that there's always some code that needs to go first. So what we actually need to do is we need to tell our compiler exactly what hardware we're running, because we're compiling for something else, we're not compiling for our own computer. So we say the microcontroller MCU is equal to, in my case, it is an Atmega 644P, which is this device just here. This is the 328, and this is an ARM, so it's not relevant. And if we have a look at the size now, we can see it's added a considerable chunk to that, but most of that is just the vector table, so basically making sure that the device resets properly, and just initialization, very basic. The next thing we want to do is we want to program our device. So the AVR GCC binutils or binary utilities suite comes with a tool called AVR Dude. So AVR Dude is the AVR downloader and uploader. We can use this to do a whole multitude of things. We can read the RAM, we can write to the RAM, we can read the EEPROM, write the EEPROM, and we can do the same with the flash. Most of the time you'll just want to write to the flash. To write to the flash, what we want to do is first tell it how we're going to program. So for this device here, I'm not actually 100% sure what the programmer is, because I normally use the Arduino IDE, but the Arduino will tell you what the programmer is, so that's fairly simple. For this has a custom bootloader based on the USB ASP protocol. So that is our programmer. Then we say, oh wait, no. C is programmer. Then we specify our part number or our device. For this again, it's an Atmega 644P, so we say M644P. And then finally we tell it what to do. So we want to use it to act on the flash, we want it to write, and we want it to write our a.out. So if I do this now, we get a little error, basically saying can't find the bootloader. For this device, I just have to push a little button, puts it into bootloader. You can probably see the LED. Yeah, so if I push it again, there's a little LED, actually. Oh, there you go. So I've got the little LED, I push the button, and the LED comes on to say that the bootloader is active. So if I run the AVR Dude again, this time it programs successfully and it does absolutely nothing, but we haven't told it to do anything. That is very simply how to get your environment set up. In the next video we're going to be looking at some basic input-output or general purpose I/O, GPIO, and how to control it. Look forward to seeing you next time. Hope you enjoyed the video. Leave a like, subscribe, and I'll see you all soon.